The scientific revolution starts now.
The Deep is the Science Podcast.
Let us see in the dark.
People are moved by different things, but for me, understanding something is a real joy. And so I think most of my life, I've always tried to understand things around me, physical things. I've never been much good with humans, but I'm pretty good with physics.
And in terms of the physical systems that you've sought to understand, has there been anything that drives your passions towards one system versus another system? Or is it just that there are problems that come across your desk and you decide that these are the things that you're going to focus on for a while, and then you figure them out and then you just move on to something else?
Well, it's sort of more accident. All of our lives are governed to a large extent by accidental factors that we don't control very well. You get born, that's kind of you don't have anything to do with that. And so you have a life, it's a limited life. I've lived longer than most, but I've tried to do something useful from it. And so I think we should all try to do that. You don't have to do it in science. There are many other areas that you can live a good life with. And people, I think, should be guided with that, given the years that you have to live, make it worthwhile.
That's definitely true. But I wonder if you've done things as diverse as working out systems for astronomy, as figuring out how to quantify spin inside of physical systems. You've worked on climate. This is just such a big span of topics, which is rare because I feel like in academia, people will usually find a row and they hoe it, and then by the end of their career, there's this very distinct path of topic to topic to topic to topic, which is just what it's done is it's taken the thing that they've started and it's expanded it, but there's still this clear connection. And I feel like among the people that we've spoken to, you're characterized by having this really broad diversity of interests, which is very unique.
Well, I think in my case, I was influenced as a preschooler because I was in Oak Ridge during World War II, and my mother was the first doctor at X10, what's now the Oak Ridge National Laboratory. So when she would go to work, I was surrounded by chemists and mathematicians, and so it was much broader than physics. Biologists, we were very interested in biology then because people didn't really understand very much about how radioactivity affected living things. So I think that probably influenced my life and would have been different if I hadn't had that experience.
Did you sense any anxiety about the radiation crisis at the time? Was it a scary atmosphere, or was it one more of just curiosity, like we've unlocked this
Well,
new
I would say
secret?
it was more frustrating because people didn't really understand very much at that time. It was already clear that you could cause great harm to people, for example, by swallowing radium. We already knew about the poor girls who painted watch dials with radium in New Jersey, in the 20s and 30s, and many of them had already died horrible deaths from bone cancer. So that was known, and but not very much else. And until then, the amounts of radiation around were fairly small. There were X-rays, and you may remember, at least I do, that you'd go to a shoe store and you could look at your feet, through the shoes on an X-ray machine, and of course you were getting a horrendous dose of X-rays, but nobody paid much attention to it. And so my
And
mother
most of you
was
still
a
have your
doctor.
feet too. Everybody still seems to have their feet for the most part, surprisingly.
Well, it was really fun. You could wiggle your toes and you could see the bones moving. And you could see the nails, the iron nails in the shoes. It was very interesting. I loved doing it. It doesn't seem to have caused me any harm after that time. And that's probably correct because as we've learned more, radiation has to be handled wisely, but, its dangers are greatly exaggerated. Background radiations vary by factor of 10 from place to place on the Earth. And you can't tell any difference from the populations living where there's 10 more times background radiation than when it's 10 times less. It just doesn't seem to make any difference. But my mother didn't know what to do. And every now and then they would get some bad contamination. And one thing about radiation, it's easy to detect. You take a Geiger counter up to the person who's been contaminated and it goes clickety click click. It sounds very threatening. And so they didn't know what to do. They scrubbed them down, with soap and water, and they put the Geiger counter up. They were still clicking away. They'd scrub them again. And of course, my mom would come home and she was clicking away too because she had been exposed. And so they were sort of doing it on the fly, trying to be responsible. Actually, we had a lot more problem. My mother complained mostly about the Army, which was running Oak Ridge at that time. And, it was a very secret location, and you had to take a bus from the village of Oak Ridge, which had been built, in just a few months. And it was all barracks and, dirt roads, and all the roads were dirt. And so when the buses would go to the plant every morning, there was this cloud of dust, that you could see for miles around, because of all the buses and the dry roads, and all the workers would inhale the dust, and then they would have terrible, lung problems and coughs. And so that was really a much bigger problem for my mother than radiation. And I remember her being frustrated that she couldn't get the Army colonel in charge to oil the roads. And his answer would always be that this would alert German spies that we were doing something, but you could see the dust cloud 10 miles away, so you had to be a pretty dumb spy not to know that something strange was going on in East Tennessee.
It's so hard to imagine those times for someone born in our era. It's very hard to imagine the whole country united in this effort against this national enemy on the other side of the ocean. It just seems in some sense so simple and romantic compared to today.
Well, it's one of the few times in our history that we have been united as a people in America. It's a terrible way to become a united people, but it was good for America. So I would say for the first 10 or 20 years after World War II, we benefited from the fact that you had all these young people who had worked together to defeat the Nazis and the Japanese Empire, and many were academics, many of them were businessmen or lawyers or, just simple workers, but they had all worked together and they respected each other. And so they worked together very well in the 50s. And things really didn't start to unravel until the 60s, the mid 60s, with the Vietnam War and civil rights movement. That sense of unity gradually disappeared, but I had the luck to at least witness the early stages of it, and I miss it. I'm sorry it's gone.
Did you find any kind of respite in science from the social conflicts?
I'm sorry, Anastasia, could you repeat that again?
Like in the later years?
Yeah, so during the civil rights era and when the society was starting to shake itself apart because all of these divisions were being uncovered, did you feel that science was a place of recourse and respite? Were you able to bury yourself in the science and see it progress in a way that was still this unified, idealistic push towards some kind of deeper unity?
Yes, that's a good point. That at least in the 60s, science was still a refuge, where you were motivated by trying to understand how the world worked, and things were still happening. There were exciting things being discovered in the 60s that still are, but you could focus on that, and then you could kind of ignore the other bad things that were happening. Although even in science, in the late 60s, young people going into science were worried about being drafted. Young men, they had draft cards. They could be called up. Some of my good friends were killed in Vietnam. It was a tragedy. It was a tremendous waste. And so we weren't completely insulated from the real world. And it's gotten gradually worse, I would say, since then.
Yeah, was there a hinge point where things really started to trickle in from the outside world into the academy, and you started to feel the pressure of politics inside of the academy? Do you remember a point when that switched?
Well, there was tremendous recriminations in the late 60s, early 70s related to the Vietnam War. And many people felt that academia, at least the hard scientists, had sold out to the military-industrial complex. And, both of you were at Columbia, I understand, and that's where I was at the time. And it was a tumultuous time. There were sit-ins, there were building takeovers. I was held captive for several days, and my wife had to come and, throw sandwiches through the window so I could get something to eat. And and then there was the Congress didn't know quite what to do. There was this famous Mansfield Amendment, which cut off a lot of funding to the hard sciences, physics, chemistry. So it was hard to keep research going. There was a shortage of money, so just everything seemed to be going wrong. And
what was that Mansfield Amendment? I'm not aware of that.
well, I've sort of forgotten the details, but it was that money going into research for military purposes.
I just looked it up. So it looks like in 1969 it was passed as part of the fiscal year package for 1970, and it prohibited military funding of research that lacked a direct or apparent relationship to specific military function.
Right. Yeah, that's right.
That
That's
seems because I mean,
exactly
like a
right.
lot of the money comes from DARPA right now for stuff that just doesn't really have a direct link to military research. So I imagine that must have been an enormous blow. Because was the military funding a
Well, of
large
course,
swath?
yeah, as part of this good feeling that I mentioned that came out of World War II, the military was very generous to academia. They provided money for doing physics research on things that clearly had nothing to do with military goals. If you wanted to understand field theory, the Army Research Office would support you to work on on field theory. And they were not ashamed of that. Actually, they were proud of it. They felt that was making the country stronger. But it was felt then, the late 60s, as the war progressed, the Vietnam War progressed, that this had corrupted academia, and so that they were all supporting the military just because they needed the money. That wasn't true. Of course, it wasn't true at all, but that was the perception. And so the Mansfield Amendment was to cut down military funding of academia, and therefore cut off potential allies to this adventure in Vietnam. I don't know. When you look back on these things, they seldom make very much sense. They seem sort of sensible at the time, but they're often counterproductive. They do just the opposite from what you think they're supposed to do. And that was certainly true of the Mansfield Amendment.
Well, it's interesting because something definitely happened to the sciences over the course of the last 100 years or so. So there is a moment at the beginning of the century where science is progressed to the point where it's very academy based. Like, it's no longer barons in their castles mixing chemicals together and writing treaties to the Royal Society. And so we've moved into this age of the modern-ish university system. And then we have, after World War II, I think is when peer review really starts to kick off. And so when we try to figure out how science has gone so wrong, because I think that everybody here agrees that science has gone off track as a general statement, and the ways in which it's gone off track is that it's become progressively more and more difficult to express ideas that challenge the status quo.
With the result being that there's less breakthrough innovations, I guess.
Exactly. And so we're always trying to figure out where exactly that started to take place. And so a lot of people point to peer review. But I'm looking at a chart of NASA's budget of the federal total, and it looks like right around the same time as the Mansfield Amendment is when NASA's budget started to really go down. And so it seems like it's also this secondary push where there's peer review on one hand, and on the other hand, there's a lot of money that's being taken out of the academic sciences, which prevents people from being able to be comfortable in their tenured professorships and to freely pursue ideas. And so it feels like the two things are related when it comes to the degradation of the academy as a place for freedom of thought. Because if there's less money, everybody's going to be freaked out in the most basic form.
Yeah. Well, you're touching on a very complicated subject. People who are a lot more interested in it than I am have written books on it. For example, the former head of the Army Research Office, John Parmentola, has written a nice book on that, and which I recommend looking at from the point of view of a government bureaucrat who was very sympathetic to science and thought it was important for the country. When I look at it as a in the trenches scientist, I think there are many factors. It's more than just funding. For example, certain fields are really hot at certain times in history. So, for example, in physics, it was wonderful to be a physicist in the 1920s, 1930s. That time, just every year, something exciting and new would happen. A new discovery of quantum mechanics, the discovery of the nucleus. And physics is still exciting, but it doesn't have that target-rich environment that it did in the early 20s. Today, if you're a young person, if you want an exciting field, you might actually be more attracted to biologically related things, which are developing much faster. Someone pointed out to me that a good way to tell how exciting a field is to compare two textbooks that have been written 10 years apart. And if they're nearly the same after 10 years apart, it means that the field isn't advancing very rapidly. So if you look at, say, a biology textbook today and compare it to one 10 years ago or, say, 20 years ago, they're practically, different textbooks because so much has happened. But if you look at a physics textbook, astrophysics, the textbook today differs almost not at all from a textbook 20 years ago. There are a few marvelous things that have happened. For example, developments with gravitational waves have been very exciting. But for the most part, there have not been the type of revolutionary developments that are occurring all the time in biology now, and which occurred in the early 20s in physics. And you could look at other fields, all fields, they have their good centuries and their bad centuries. Science is a long process. And, physics had a good century at the time of Newton and Kepler. And then there was 100 years where not much happened. And it had, things change.
Do you have a sense of what the fruitful threads for physics will be in the future? Because I wonder if someone who preceded Newton and Kepler would have been able to look at what was happening in natural philosophy enough to be able to say, okay, we need a new paradigm for planetary motion in order for things to proceed. Or we need mathematics that are capable of describing motion for us to be able to get beyond where we are right now. And my instinct is that somebody could, because people must have been bumping up against the limits of what was known enough to be able to think that, maybe I'm personally not smart enough to figure it out, but they'd be able to see that this is where the cracks were. And so I wonder if you can see something similar for modern physics today, where you wonder about those cracks for the next generations.
Well, I think the sort of the obvious big puzzles are in cosmology, for example, the missing matter, why do galaxies rotate so much faster than they ought to rotate, given the mass that you can see in them. And so there's clearly something not right there that we don't understand. That's happened before in physics. Nobody, for example, ever understood how the sun worked in the 1800s. There were various guesses as to where the energy came from, but they all led to very, very short lifetimes for the sun and the earth. And it was in complete contradiction to geological evidence that showed that the earth and the sun must have been around much, much longer than physics could predict. Or, Maxwell's theory of radiation and thermodynamics showed very clearly that there had to be infinite amounts of ultraviolet energy floating around the universe. And that was clearly not true. You could just look and see it wasn't true. And so there was clearly something wrong, but it didn't make people despair. They continued to use classical thermodynamics and Maxwell's equations. And, we got radio transmission and all sorts of wonderful things from it. But it wasn't until Planck came around in 1900 that the mystery was finally solved. And so that was actually solved because of a clever theoretical concept of quantization that Planck came up with. But other things have developed just because of accidents. Most of nuclear physics was an accident. Becquerel noticed that his photographic plates, got darkened by these rocks from Silesia or wherever they were. It was uranium ore, and it was darkening his plates. And the early to work on gamma rays, they discovered this peculiar mixture of beryllium and radium that made something that looked like a gamma ray, which was even more penetrating, and that was the neutron. But it was an accidental discovery. It took several years to figure out what was really going on. So physics is full of major changes that have been just accidents. No committee predicted them. It was just some bright people noticed something that was unusual and were able to disentangle what was happening. You see unusual things all the time. There are dirt effects in a lab, Dreckeffekte, in German. And if you spent all your time tracing them, you would never do anything else. Only a small number of them turn out to be important. Yeah.
I thought it was really interesting.
You have to pray for continued accidents and continued presence of bright people who will recognize that the accident's important.
And pay attention to those blaring contradictions too. I just thought it was really interesting what you said about how the technology proceeded in spite of the fact that we didn't have this idea of the quantum, right? There was just this anomaly with the ultraviolet radiation that was just kind of sitting there and bothering people, but that still the technology was able to proceed with the old theory no problem, which is just really fascinating that you could have. I think this is where the confusion between science and engineering sometimes works against science, because people think, oh, well, everything's fine, we can build things, we can send spaceships into, to visit the moon, but we might be missing something more fundamental, and it takes that really glaring contradiction to be resolved before you can do that.
Mm-hmm.
Oh, go ahead.
I was going to say, you usually just ignore the contradictions,
Yeah.
just live with them the way we're living with, what is the dark matter,
Mm-hmm.
It doesn't bother me when I go to bed every night. I don't understand what the dark matter is. I'd love to know, but I hope I live long enough to find out what it is. But I don't lose sleep about it.
Mm.
Yeah, we had a really interesting conversation with a Stanford astrophysicist a few weeks ago who is among the first scientists to really be looking at the role of magnetism in galactic formation and galactic cohesion. And I just feel like we're in such an infancy of looking at things other than gravity that might be playing a role in the situation that I wouldn't be surprised if the solution comes from a completely different lens, somebody else looking at it from a very different, the same problem, but not trying to solve it in the same way that people have been crashing their heads against the chalkboard for the last
It's
few
happened.
decades.
It's happened more than once in the past, and it probably will happen again.
I have a really basic physics question that I have never satisfyingly answered for myself. And so forgive me for the very basic and perhaps naive question. How does quantization solve the ultraviolet catastrophe? I know that it does, but I don't totally understand how and why.
Other than a mathematical solution?
Yeah, it was a mathematical problem because, the blacksmith who heats the piece of iron till it's red hot so he can work it with his hammer, he could care less that it should be emitting infinite ultraviolet. He knows perfectly well it only emits red light. So it was the mathematics of why there isn't all the ultraviolet, which Planck solved. But the basic reason is that the electromagnetic field has infinite number of modes of shorter and shorter wavelengths. So there's an infinite number of them. And classical thermodynamics said that each mode had to have kT worth of energy, right? So you multiply kT, which is a perfectly, K is Boltzmann's constant, T is the absolute temperature. You multiply that by infinity, you get infinity. So that was the problem. So what was wrong? It was not the infinite number of modes. That's true. What was wrong that it's not true that kT is the energy per mode if you have quantum mechanics, because if there's a finite energy, you freeze out that energy. So the high frequency modes, the ultraviolet, the X-rays, they don't have any thermal energy in them at all. At least not for normal conditions. They do in a bomb or in a supernova, but not normally.
So is it a matter of integrating all of the other states and considering the energy as a whole of that black body?
Well, black bodies are sort of central to physics, and yet we don't pay very much attention to it. It's actually not that easy. Speaking as an experimentalist, I can tell you it's very hard to make a black body.
Mm-hmm.
If you try to make one, most of them actually reflect a little bit of light, and they have emissivity less than 1. So the classic way of getting an effective black body, I'm sure you remember, is you would have a cavity with a tiny hole in it. And the idea then was that if a photon would go into the hole, even if the walls were not completely black, it would have to make a number of bounces. And there were so many bounces and so many chances that it would be absorbed that almost none would come out. A little would come out, but it was pretty black. So that was the classic black body source. It's a tiny hole in a cavity.
Hold on. I hate to interrupt you, but your camera has gradually slipped, so we can just see your forehead.
What is that?
Your camera has been gradually slipping, and so we can see
There
less
you
and
go.
less of you. That
Sorry,
sounds
We
better.
were just looking at the top of your head.
My hand too vigorously.
I'm sorry. Continue.
Yeah,
The black.
yeah.
So it's difficult to make a black body because there's a little bit of emissivity, even when you're making a basically perfect container.
That's right. And so the class.
Pardon the interruption, dear listeners, but we must ask you for a favor. If you like what the Demystify Sci podcast does, consider coming over to our Patreon. It is at patreon.com/demystifysci, and there you can contribute a couple dollars a month to help us keep the ship running and allow us to continue our investigations into the most interesting ideas that are out there about nature humans, history, the future, technology, economics, all of the things that we do on the podcast. In return for your donation, you get both of our episodes for the week early. You get to join our fantastic patron chat that meets weekly on Sunday mornings to talk about everything that is interesting in the world and the direction that the podcast should take. And you get to have the satisfaction of contributing to something that you think is important in the world. If you can't contribute right now, that is totally fine. We understand. I have been in that boat for many, many years. But what you can do without spending a single penny is come to our Discord, come to our Facebook, come to our Twitter, come to our Instagram, like, comment, and subscribe, because by helping us with the algorithm, you help us grow in a really super passive way. And if you've already joined the Patreon, just do all that other stuff too. For now, back to the conversation.
The classic way is you try to make the photon have many bounces when it hits something, and each bounce has a reasonable probability of absorbing it. And if you have enough of them, you're almost sure to absorb it. There's always a little bit that escapes, but for example, that's why black velvet looks black. It's not so much that the textile is black. It's because the light comes in and it bounces off the little fibers many times before it can get back out, and so that makes the fabric look much darker than it would be if you just had a woven fabric of the same thread. And so black bodies on, say, satellites that they use to measure say microwave radiation come out of the earth look like black velvet, sort of versions of it. They have lots of little fingers of absorbing material coming up, and so a microwave has to bounce many times and it gets absorbed, and vice versa. If you control the temperature, it emits like a black body, so you can calibrate your instrument with that.
And the rationale being that you need to have perfect absorption so that you can claim that the radiation is thermalized.
That's right. That's right.
Why is it important for the radiation to be thermalized?
Because you're trying to characterize thermal radiation in the first place. And if you're characterizing reflected light or something else, then you're not looking at the thermalization, the absorption and re-emission of that light by the body.
I see. So the body has to be, you're basically
It has to be in
measuring the
thermal
reaction
yeah.
between the light and the body at the end of the day.
The emission of the body in particular, yeah, due only to temperature, ideally. But so the quantization of that, just to make sure that we answered your question.
It is a mathematical construct that basically prevents you from having the impossibility of infinite temperature at the ultraviolet range, because Planck realized that you can have infinite modes, but that those modes wouldn't carry as much temperature. Is that basically the case?
Each mode, classically, each mode had the same amount of energy, and it was K times T. K is Boltzmann's constant, and T is temperature. And so there are infinite numbers of modes, so there would have to be infinite energy, thermal energy. And everybody knows that's completely wrong. It's maybe it's even a problem for the water or for ordinary matter. They have specific heats that have to do with phonon modes. The molecules are vibrating inside, say, a piece of glass. And if you calculate what its heat capacity should be, it's normally got less heat capacity than what you measure is usually less than what you calculate. And that's because even in a piece of glass, some of the modes are frozen out. Their frequencies are too high. So they don't have that KT worth of energy that classical thermodynamics predicts. It's a wonderful prediction, and it's really true for low enough mode energies, but it fails if your energy gets high enough. So that was a wonderful insight that's due to Planck,
So the quantization freezes out the higher energy modes, the higher frequencies.
The fact that the high modes get frozen out. Yeah, that's right.
Frozen out here means that they just don't.
They contribute less to the thermal spectrum through the introduction of this constant.
Why, in reality, do they contribute less to the thermal spectrum? Like, why does something that's vibrating in the UV have less heat than something that's vibrating in the IR spectrum?
I
theoretically.
think it's more like the heat is less exciting the UV frequencies than it is the the ones in the longer wavelength, something like that.
Yeah, the difference is that if the energy, the mode in the UV, take a typical hard UV photon might be 4 electron volts, that, I like to think in electron volts, and but thermal energy is about 1/30 of an electron volt. And so the UV mode, instead of having a 1/30 of an electron volt, turns out to have the exponential e to the minus 3 evolts divided by 1/30th of an evol electron volt, which is what does that come out to? Well, 30 times 3 is 90. So e to the minus 90. So it's essentially 0, right? So it's because you go from something that's proportional to temperature to something that's proportional to exponential -1 over temperature, which really goes to 0 fast, and so that was Planck's insight. He was the one who figured out how this happens. And then
And from
once that insight came, it explained just a host of things very rapidly. You could look around the world in 1900, 1905, 1910, and it was full of things that were inexplicable without the assumption of quantization of energy. Heat capacity that I just mentioned was one of them.
yeah, it sounds like from like a threshold perspective, those frequencies just don't have the energy available to them to excite a photon in those higher frequencies.
I guess I have with physics, I always try to think of the material and the way that it's moving in order to create the effect. Like, I understand that field theories say that thinking of direct material is not the right way to think about it, but it tends to be very mathematical the way that people do physics. And for me, the math is like, it's kind of this gloss over the world for me. And so I try to visualize what the objects are doing. And so it makes sense to me that something that is moving in a specific way can transfer energy as heat. But when we get to the UV spectrum, I'm trying to think of why is it that they're moving in such a way that they can't transfer heat? And I'm still I'm still like at a loss, but I don't know that anybody has
I
the
think it's
answer
more
for
just
that.
you're thinking of it a little bit backwards. I think it's more just the heat is only capable of exciting those other modes. Like the higher frequency modes require too much. They're not reaching their threshold for generating photons, something like that.
But look,
That's what I'm thinking.
Anastasia, you're right to be focusing on observable facts. And so I think Planck also was focused on observable facts. He knew that the ultraviolet, infinite energy was wrong. You could just see that everywhere. And so he tried to understand exactly how is it that classical physics predicts this. And he realized that one way you could get around it was if the energy absorbed had to be in quanta instead of little tiny packets, as little as you like. It turns out it's not possible for a UV mode to absorb a little bit of energy, a 100th of that energy. It has to absorb it all or none, right?
And
So it's
that's
sort
what
of
I
this
meant by the
all or none
threshold. Yeah,
issue that
like the glass is just not being filled up enough, basically.
I see. It's not being driven hard enough to produce
Yeah,
the.
by the thermal input.
Yeah. Okay. All right. That makes sense. I'm satisfied with that.
Yeah. So
we tend to forget how important thermodynamics was in the development of physics. It was very, very important in the development of quantum mechanics. It was what really drove quantum mechanics. It wasn't accelerators and particles, or radioactivities. It's trying to understand this problem with classical thermodynamics. And once you fix this, as Planck did, classical thermodynamics works fine. We use it all the time today with quantum theory, and it's okay. What you predict is what you measure.
Hmm.
It also seems like he had the benefit of Einstein working on the photoelectric effect, which had a similar quantization feature, almost overlapping in time. I think they were working on those problems probably, I don't know the dates, but it was basically the
Yeah,
same
the
period.
basic ideas are similar because nobody could really understand the photoelectric effect. This is the idea that, when you shine light on a piece of metal, if the light wavelength is short enough, electrons will pop out of the surface, and they come out with less energy than the photon. Speaking in modern language, people didn't know about photons then. But there was an energy that increased as you increase the frequency of the light. People knew light had a frequency, and so it was as though all the energy of the light was going into a single electron, and that didn't make very much sense in the early 1900s, because that's counterintuitive to everything else you see in life. If you add a little bit of heat to a cup of coffee, it gets a little warm. You can add a little more, it gets a little warmer. It's not something that's quantized. You can in an analog way just add as much as you like, little bits at a time. But that wasn't the way that electrons came out of metal. And Einstein's explanation for that, as Michael said, was that it's because a photon hits the metal and all the energy of the photon goes into a single electron, and the electron then has enough energy to pop out of the metal. It's pulled back to the metal by its image charge and other quantum mechanical forces. But
it's always an electron. You never get like half an electron or something.
That's
It's kind of
right,
a similar
yeah.
thing that it points at this sort of threshold of action, which is really interesting. And Planck called it the quantum of action originally too. That's worth pointing out, which I think is really informative. It's like the least amount of action that these atoms are capable of, given some energy input.
It's interesting to me
it's a
how
funny concept. Action is it's energy times time, and
Mhm.
when you first study mechanics, that is not a natural unit of anything that you work with. And so it's a much more abstract thing than you first suspect. But Michael's right, it's the quantum of action. It's the smallest action you can have.
I'm struck by the circularity of history in some way, because I've been reading a lot about the opening of the Age of Reason and Descartes and his vorticular model of the universe, and the idea that they were finally getting rid of Aristotle for the first time in the 1600s and really making the case that maybe it isn't the doctrine of substantial forms. Maybe we can explain things by matter and motion. And one of the first questions that they were really preoccupied by was the mathematics of vibrating strings and trying to figure out how you change the relationship of the string length and how you get different tones and what music actually is. And it seems like what happened at the turn of the century here was like the mathematics of vibrating matter. Like whereas before it was in the macro scale of, okay, we have a musical instrument, how do we talk about what the strings are doing? Here it's how do we make the mathematics describe what the atoms are doing now that we have already decided that atoms are a thing.
Yeah, you're right. Vibrations or periodic motion is absolutely fascinating, and it's sort of at the heart of how the world works. The creator really understood vibrational motion. And the Greeks, Plato and his school, they were very interested in music, and they knew a lot about vibrations and how tones would change. And I think they clearly understood it was because the string was vibrating that you could hear the sound. But the mathematics of that really had to wait until invention of calculus. And the real hero there was Fourier, the French mathematical physicist, who was, by the way, very interested in heat and heat transfer into the earth and through materials. But he was the one who showed how to use the calculus to analyze vibrational motion, oscillatory motion. And, that's sort of at the heart of almost anything a physicist or an astrophysicist or any quantitative scientist does today is this idea of vibrational motion, that things have frequencies. A mode is a vibrational frequency, and
that you can deconstruct these complex oscillations into more primary ones that you can actually examine using these kind of old Greek trigonometric methods.
Yeah, that's a very profound thought, and very, very important. It's so important we just sort of stop thinking about it, but it's not obvious when you think about it. Well, how could that be? and
It's interesting. I feel like the early geocentric models, the Ptolemaic models, where you deconstruct things into these circular epicycles that have infinitely more complexity to get closer. They're so close to the idea of a Fourier transform. It's really, really, really close, but they didn't quite nail it.
They are close. They're very close. Yeah. And you can, of course, analyze them with Fourier analysis today. It's a pretty good model, actually. They were able to predict eclipses and things like that. It was not something to be scorned.
So maybe we can pivot, because I want to talk about your time. You at some point moved away from the radiation lab at Columbia, and you, I think you went to Princeton after that, but you also spent some time with the Department of Energy, which is a really interesting transfer.
I went down to Department of Energy for 2 or 3 years in the early 90s. And I was the head of the Office of Science then. Now, I guess the undersecretary or the assistant secretary for science. They've changed the name, but it was all the non-weapons basic research in Department of Energy. So it was high energy physics. It was we're doing a lot of work then on the Human Genome Project. Again, going back to effective radiation on humans and genetics. A lot of work on geophysics. And so it was a fascinating job to have. I learned a lot while I was there. I enjoyed learning. And it's, of course, frustrating, too, because you spend most of your time worrying about next year's budget. You feel like you're responsible to all these researchers to try and get the money again next year. So I have a lot of sympathy for the people at NASA, NOAA, and DOE who exaggerate the importance of research, because unless you do that, your budget will get cut. And so it's really not a very good system. And I don't know how to fix it, but
yeah, I'm curious how did that invitation come? Was it an easy decision for you to make to go and join this bureaucracy, or were you a little bit hesitant because you wanted to stay in the trenches with the science more? Or?
Well, I knew it would only be a temporary job, that I could go back to doing research when it was over. And I guess I thought, if I don't do it, maybe somebody worse than me will do it. And so I thought I could give it a try. And so I always tried to keep the researchers and the research as my first priority. And I spent all my time trying to figure out how to get Congress to support, the research community, the DOE research community. My biggest headache then was the super collider. That was the days when the superconducting super collider was being built in Texas, and there was enormous opposition to it. And actually within the sciences too. Many of the scientists were jealous of the money that was going to high energy physics, and I kept trying to explain to them that this is not a zero-sum game. That if you succeed, solid state physicists or you geneticists, if you could succeed in killing the super collider, they won't spend that money on genetics or solid state physics. They'll spend it on 4 or 5 new F-16 fighters. So it's not a zero-sum game. But nobody seemed to understand that, and so it was very frustrating. And the super collider was still alive by the time I left, but it was just barely alive. And a few months later, it was canceled.
Mm-hmm. Now, the issue of the ozone hole was being raised while you were at the DOE. Is that
Yeah,
correct?
that's right. Yeah.
What happened with that?
Well, that was the sort of lead-in practice session for the current climate, emergency, so-called emergency. But ozone was known to react with chlorine and be converted back into molecular oxygen, so it could no longer absorb ultraviolet radiation from the sun, UVB, the radiation it's able to absorb. And so there was not very good data, but it was clear that, the standard freons that we used then for refrigerators had chlorine in them. They were really good refrigerants, and they were cheap. They worked very well. And but a lot leaked out into the atmosphere, and you could see that the freon levels were slowly building up in the atmosphere. That was easy to measure. And so the worry was that this would cause ozone depletion and therefore more ultraviolet reaching the surface. Nobody cares about ozone in the stratosphere. What you care about is the ultraviolet reaching the Earth's surface. And so my problem was that, we had quite good measurements then. I paid for them, so I knew about them, that UV was not changing at the surface. In fact, most places, the ultraviolet reaching the surface was going down, not going up. So I didn't even have the right sign. And yet we were making these decisions which were going to be expensive. It wasn't like climate. It wasn't like CO2 where you're talking about truly suicidal policies. But then it was going to be expensive because you would have to replace all of our refrigerators and stuff with new refrigerators with refrigerants that were not as good as the freon. And yet there was no evidence that the supposed harm freon was doing was even happening. And in fact, to this day, that's true. It's there's been no real change of UV. If anything, it's down. And so I said, why are we rushing into this until we really understand that there's a problem? There's no sign that there's a problem, and this will come at a cost. Well, I didn't get any support. Everybody was against me. The virtue signalers, we got to save the planet. They were against me. The DuPont was against me because the patent had run out on freon, and they had this new refrigerant they were waiting to sell, which was under patent, and so would cost 10 times what freon did.
Oh, that's
And everyone would
fascinating. I
have to
did
pay
not know
for it.
that.
And so industry was against me, politicians were against me. So I lost it. Al Gore was against me because, this was part of his campaign, saving the planet from saving the ozone layer.
And what about that hole too?
But I refused to shut up. I kept pointing out that there's no evidence that UV is increasing, and that's what we really should be worried about.
But what about that hole? Because they made this claim that as soon as they stopped using these CFCs, that the hole closed up. But I noticed looking at it that it's back again.
No, it's not made any change. The ozone hole has probably always been there from time to time, and it's mostly natural, and it has nothing really to do with the theory that was being promoted at the time that this was a homogeneous reaction between chlorine atoms in the stratosphere and ozone. The ozone hole forms because of heterogeneous catalysis, on ice crystals, sort of witch's brew ice, has a lot of nitric acid and other junk in it. And, at the end of the winter, as the sun comes up and starts to shine on these ice crystals, and then there are reactions as the ozone attaches to the crystal, it gets destroyed. But it's a heterogeneous catalysis, like what we use in petrochemicals, to make gasoline. It has nothing to do with the prima facie cause of the Montreal Protocol.
How
The
long?
hole is still there.
Yeah, it is.
It's still there, and it's funny because you look at NASA projections for when it's supposed to be closed, and it's very the data's real messy on that. But something that I've always wondered is, do you know how long we knew about how long were we tracking the ozone layer around the planet before the political cause around ozone nucleated?
Well, I'm not a terribly good historian of science, but I think we started getting rough ideas about it in the 20s. There was this Englishman, Dobson, who was very interested in not so much ozone, but in transport, because, ozone is mostly made near the equator, and then the winds in the stratosphere carry it to the poles. And so it's a wonderful tracer to tell how stratospheric air is moving around. So Dobson had noticed that you could just look at the solar ultraviolet at the ground level and you would know, how much ozone was overhead. And so he developed instruments, and even today we measure ozone in what they call Dobson units. It's how much the solar UV is attenuated. And so I think that data was around at least by the early 30s. There was crude data. And there was some evidence even then that there was probably a hole, but they don't like to admit that. But it was not really until the satellite era that we began to get high quality data. And so once you've got satellites and you're getting high quality data, you see all sorts of surprising things because everything is new. And so everything is surprising. But it doesn't mean that it's something that has never happened before. You just didn't have satellites, so you've no idea what has been the sort of the background physics of the atmosphere. So
Yeah,
anyway, it didn't matter that much. DuPont made a lot of money, and
was DuPont leaning into the climate narrative?
well, I don't. They were certainly very much into the ozone thing. They were very much in favor of the treaty, and it was very profitable for them. And I don't know. I don't think they've been very active on climate, which is sort of different because it's much, much bigger, ozone thing, you're talking not a lot of money, some inconvenience, less efficient equipment because the new refrigerants aren't as good. They're not as safe. And
Hmm.
but with climate, you're talking about, trillions and trillions of dollars, so it's a completely different order of magnitude. And so there are different forces involved here than there were with the ozone. Ozone you could live with, it was stupid, but, there are lots of stupid things that happen in life. This was not tragic.
These trillions and trillions of dollars you're talking about in the modern era, are those subsidies for green energy? Is that what you're talking about?
Yeah, if you get rid of fossil fuels, there's no way to do that cheaply and efficiently. If you just look at what's required to replace them, it's a good fraction of our land would have to be covered with windmills and, solar panels, and, they're extremely expensive. They're environmentally destructive. And so it's really, people haven't thought through this. It's a nightmare coming down the tracks. It's a real train wreck. It won't happen because people won't put up with it, but it can cause a lot of damage before it's finally stopped. And so my hope is that there's still enough rational people in our society that we will stop this before it comes to a crashing end. Something sort of like this happened in Ceylon 2 or 3 years ago, where they got a government that was going to go back to organic farming, and so we're going to do everything with compost, and we're going to ban chemical fertilizer and ban gasoline. So you go back and do it the way your ancestors did. And well, the results were completely predictable. Within a year, the rice crop had failed, even the tea crop failed, prices of food went up by factors of 5 or 10. People were starving. There were riots, and they stormed the presidential palace, and the president had to be evacuated by helicopter. Otherwise he would have been hung. And so that's something that you don't want to repeat, in our country or any other country because of idiotic decisions. But it could happen. And, you look at California, they're talking about getting rid of all internal combustion engines. You simply can't do that, and so it won't happen. And so it could, you can keep it from happening in a rational and civilized way, or you can let it happen the way it did in Ceylon. But in either case, it won't happen because people can't live. It's a suicide pact.
We lost your head again. I'm sorry.
Oh, sorry. Yeah, whenever I get excited, I bounce things around here.
It's funny
Okay.
because the story of what happened in Sri Lanka reminds me of Louisa May Alcott's father was a diehard utopian, and he bought a plot of land and they called it Fruitlands, but he was a vegan and believed that it was immoral for man to use beasts of burden, and decided that he was going to farm without any of the oppressive things that people had done up until that point in order to make productive land. And they basically spent 2 hungry years on this really infertile plot of land, and I think almost died, and then eventually just kind of gave up on it and left because it was an experiment that couldn't be performed enough to even support a small family in New England, let alone on the level of a country. And all of the, like, on one hand, I understand why people want this transition, right? Because there's an idealism that underpins it that says that we are going to transcend the extractive nature of life. We're going to become more like plants that are the primary producers rather than like the apex carnivore that sits at the top of the mountain and just consumes the bounty of all of the creatures beneath him. And so I get it. Like, I understand the impulse. And what I really wish was possible was for us to balance the impulse with a level-headed ability to move towards it. Where instead of wind and solar, we figure out nuclear, where we don't need to have massive quantities of batteries that haven't even yet been figured out. But it seems like there's a very, very particular push towards only solar and only wind
I
at
think
the
you'd still need batteries for if it was nuclear, right? Because the car's got to drive around and everything.
if you that's true. That's true. But you need fewer
But
batteries.
I hear what you're saying.
Or you could have, I mean, why not have like a tiny little thorium reactor inside of every car? I just, if we're gonna be
Nuclear
dreaming
car
about,
crashes.
yeah, like if we're gonna be dreaming about the future, should we not be dreaming about the future in a way that pushes beyond the limitations of the systems that we have now? Like, somebody has to dream, otherwise things don't change. And so I wonder how you think about a different future. Because we can't keep doing things the way that we've been doing, if only because at some point we will run out of oil.
Yeah, okay. Well, you've raised a lot of good points. I mean, the first point is that I think everybody wants to live in a clean, beautiful environment. And so maybe there are a few exceptions, but I don't think there are many.
Mm.
And I certainly feel that way. I know you do. And it is true that if you live, you affect the environment. And so you have to somehow balance wanting to live and wanting your family to live and keeping the environment clean. And so we can find a balance to that. I mean, for example, many people who are worried about the environment are concerned about human population. We have too many people. And well, the way you limit the number of people is you make them prosperous. And all of the prosperous parts of the world, birth rates are not even replacement. If it were not for immigration into the United States, we would be losing population. That's true of Western Europe, that's true of Japan. It's even true of China now. China is sub-zero growth at this point. And so I'm not sure whether that's good or bad. If you lose too many people, we will all become extinct. But at any rate, the idea that keeping people impoverished somehow solves the population problem is just completely opposite to observational facts, that you want to make them prosperous, and you want to make them prosperous in a way that doesn't mess up the environment. And we can do that. If you look at a modern society, say you look at a gas-fired plant, you can hardly notice it. Almost nothing comes out of the chimneys. I've been to plants, and on a dry day, we have a dry day here in Princeton today, and you look at the chimneys, it's it's in operation, but there's nothing coming out. There's no smoke, there's no steam, there's nothing that you can see. Of course, there is water vapor coming out and CO2, but you can't see them. It's very hard to replace hydrocarbons. You and I, we store our food as hydrocarbons. That's really why they're around, is because from the beginning of the world, life has stored energy as hydrocarbons. Fat, in our bellies is hydrocarbon. And there's a good reason for that. It's very compact. It has high heat of combustion, whether you're burning it in a engine or whether you're burning it biologically. And so I think that if hydrocarbons run out, and of course they have to run out, there's conservation of matter. At some point they will run out. I think what we will do is we will figure out a good way to make affordable energy, and we will make synthetic hydrocarbons. And that's not hard to do. We know how to do it now. You need carbon and you need water, and you can get the carbon from limestone, or maybe suck CO2 out of the air. There are all sorts of ways to get carbon. Most of the carbon in the air most of the carbon on Earth is in limestone. There are thousands of times more in limestone than there is in the ocean or the atmosphere. So I'm wandering a little bit, but I think I would summarize by most people are moved by good intentions. They're not, I don't know of many people who really want to do evil, who take pleasure in doing evil. And so people who want to fix the climate, I think, are moved by good intentions. But, there's this old proverb, the road to hell is paved with good intentions. And you mentioned one example with this utopian farm, but just having good intentions isn't good enough if you really want to be effective. And so I think the climate zealots today have been badly misled. They don't understand what they're proposing, that it really is suicidal fundamentally. I noticed on Rogan's show just a week ago, they interviewed Elon Musk, and he commented that, the extreme environmentalists, it's a suicide pact. And he's right. If you do everything they demand, the human race won't survive. Yeah.
We are delighted to announce that Demysticon 2024, our very first scientific conference, is officially launched, and you can buy tickets right now at the link in the description, and also in the link that is up in either this corner or this corner. We are going to gather in Austin, Texas on April 7th and 8th of 2024 for 2 days of talks on consciousness, mythology, archaeology, solar physics, hypnosis, and much, much more. Buy tickets now, up at this link. I wonder if we couldn't talk about what happened in Sri Lanka. Do you know the details of what exactly caused them to take on this really kind of absurd policy with regards to fossil fuels and agriculture?
Well, you know, I think it's pro bono publico, as they used to say, for the public good. I don't think most people have got the scientific background to appreciate how damaging these extreme environmental policies will be to our life and our children and our grandchildren. And so I'm much more worried about them than I am about myself. I don't know, I'm happy every day when I get up, so I don't have much longer to live here. But I'm hoping that our future generations will have even better lives than we've had. And they can't have it if we adopt these policies that are being promoted, net zero. It's really suicidal. You really can't get net zero emissions of carbon dioxide. There's no reason to do it. It's very damaging. The only way you can make that happen is with enormous it almost has to be a totalitarian system to make that happen, because people don't like starving to death. They don't like being told that, you can't go more than 100 yards from your home. All of these crazy proposals that are being proposed. You can have one airplane flight in your life, forget about it. Of course, the elites will continue to jet around the world, but the average person will be forbidden from taking a plane because they might emit some carbon dioxide.
They'll be priced out of it. So the sort of suicidal nature of this is just pricing out people who aren't in that super elite class from engaging in the things that they need in order to, feed themselves and keep themselves warm. I mean, there's been some incredible examples of this, right? I think it was in there was some policy, I don't know if it was in Burma or Tibet, where they outlawed these gas stoves that people were using to cook their food with, and it was extraordinarily devastating. It seems like the people that are affected first by banning combustion are not the people at the top. It's really people on the ground who are depending on these things.
Well, it's like the same thing where it's if California bans internal combustion engines, the people who are going to suffer are not going to be the ones that are driving the Teslas. It's going to be the people who can't afford to get a new car that are going to have to figure out some way of making do in a world where they still have to get to work, they still have to do their jobs. Like the material necessity of life hasn't changed because you still need to move yourself from place to place, but the rules around it have changed.
It seems like it's environmentally suicidal too, because it seems to me that the best way to clean up your environment is to make people rich, because rich people tend to take care of their backyards pretty well. And so if you're really stressing out your lower classes, you're going to end up with these situations. Like we had a family member who just went on a trip to the Amazon, and it was just, these towns were just littered with plastic bags and garbage because these people are stressed. I mean, they're living in very deep poverty, and they can't be concerned with things like how to clean up the environment. It's just not on the top of their list of things to be concerned about.
No, you're absolutely right. A clean environment goes with prosperity, and so the only way to get prosperity is you make living affordable for people. With fossil fuels for now. We've talked about in what we might do in the future, but for now, that's the only way to do it. That makes sense, practical sense. So I don't know. Recently, I guess one of my last trips to California in connection with Department of Energy, I went to the Stanford SLAC laboratory, and I noticed that outside there were a number of chargers for electric cars, put up by the Department of Energy. And so I looked at the charger, and says, plug the cable here into your car and you'll be charged from your credit card, and the charge will be 10 cents a kilowatt hour. And I thought, gee, that's pretty good rate. when I got home, I looked up what the utility rate was for the Mexican gardener who takes care of the grounds there. You know, he pays 40 cents a kilowatt hour. So you have these highly paid, PhD physicists paying 10 cents a kilowatt hour, while their Mexican gardener pays 40 cents a kilowatt hour. It's profoundly unjust. So you can't run a society at some point, when things become sufficiently unjust, society corrects itself. It's a lot like Marie Antoinette, when there was famine just before the French Revolution, allegedly saying, to the comment that the peasants have no bread, well, let them eat cake, let them have electric cars, so this has been tried before, and it doesn't work, and thank God it doesn't. It just shows that there is some sense of justice in humanity that long may it live.
I guess it's just a matter of whether that correction can be accomplished peaceably, or if we're looking at just complete catastrophe as the result of these policies.
Well, I think it'll be peaceably because we still have a tradition in most Western societies of democracy, and democracies are messy. They do a lot of dumb things, but the nice thing about them is that you can correct them without having a revolution. You can have elections and things like that. Even the elections are messy, but sooner or later, you throw out the bums and you try some new bums. Maybe they'll do a better job. So I'm optimistic that we will solve it. But in the meantime, we're doing a lot of damage, and so the sooner we solve these things, the better it will be for our society.
One of the things that you said earlier was that you can see a future where we start to manufacture synthetic hydrocarbons, which we can then burn, in effectively expanding our reserves of petroleum products indefinitely.
Mm-hmm.
And in terms of the environmental movement, one of the strongest arguments is that burning things raises the level of CO2 in the atmosphere. That causes the atmosphere to warm. That warming causes everything from the melting of the ice caps to the acceleration of aggressive weather. And this is backed up, of course, by correlative science of ice core measurements of CO2 levels, of cave measurements of CO2 levels. There's a whole body of science that basically is making the argument that as you raise CO2 levels, you raise global temperatures, and then you can make the argument that the raising of global temperatures is going to be very bad for civilization. And I wonder if you can address some of that, because we've had Gavin Schmidt on our show, who's the director of the Goddard Institute for Space Science. I always want to say GSIS, not GIS.
He's a climate guy.
He's a climate guy, and so he's, he has a presentation where he's like, this is the evidence. The evidence is bulletproof, and it's got error bars on it, and he's very certain that the correlations are causations.
Well, after Upton Sinclair lost the election for governor in California, he made this comment that's very hard to get a man to understand something when his salary depends on not understanding it. And so you have to take that into account. People like to talk about conflicts of interest, and they say, Harper and people like me are in the pay of oil companies. That's not true. I've never taken a nickel from oil companies. But the people who are promoting an emergency, every one of them is profoundly conflicted because their existence, their research funding depends on that entirely. If one of them were to come out and say, well, actually, things don't look that bad, what will happen to next year's budget? It'll be cut. There's no problem to solve. But let's talk about some of the issues you brought up. The ice cores are very interesting. We have a record that goes back maybe a million years of bubbles in ice. Depends on where you drill the core, but there are cores from both Antarctica and Greenland. And as you say, they do show that climate has fluctuated tremendously over the last million years. Every 100,000 years or so, there is a interglacial like the one we're living in now. There was another interglacial 110,000 years ago, the Eemian, they call it, based on this Dutch river. I'm probably not saying the right Dutch pronunciation. But what you see from these cores is that when it gets cold, the fraction of CO2 in the ice bubble decreases. When it gets warm, it increases, but it's always the case that the changes in CO2 follow the changes in temperature. So what the ice cores show is that when the Earth warms up, some centuries later, typically about 800 years, more CO2 goes into the atmosphere. This presumably is due to the warming of the oceans. Most of the CO2 is in the oceans, not the atmosphere. And so if you warm the oceans a little bit, solubility is temperature dependent, and CO2 will come out. So the ice core data simply shows that warming causes more CO2, cooling causes less. It doesn't show the opposite. So that's just not an argument. Second,
And is the debate just based on what follows what? Are they just so tightly correlated with one another? Temperatures rise because you have one proxy that you look at for temperatures, and you have another proxy that you look at for CO2 levels. And so is the argument that the peaks of the two different proxies are so close that you can argue about what leads what? Because it seems
I don't think there's any room for argument. It's completely clear that CO2 follows temperature. I mean, you can process the data in various ways, yeah, often with Fourier transforms, and you look at the phase relations, and or you could just eyeball it, but all of them give the same answer, that temperature changes first and then CO2 follows. And but you can go on, the Earth is much older than 1,000,000 years, and you can get CO2 proxies and temperature proxies for much earlier times. We should maybe say a word or two about the proxies. In the ice core, it's fairly easy to understand the CO2 proxy. They're little bubbles of air that get trapped in the ice. And I don't know if you've ever seen a glacier calving, but if you haven't, you should take a trip to Alaska and look at fresh ice from a glacier. When it's calved, it's deep blue. It's so beautiful. And the reason for the blue is the Rayleigh scattering from the little bubbles of ice in there. And, Rayleigh scattering scatters blue light much more intensely than longer wavelength, red. That's why the sky is blue. But ice is normally full of bubbles of trap of air. And so what you do is you melt a little fraction of that ice that the depth, so when it was deposited, and you get the air and you measure the fraction of CO2 in it. So that's fairly straightforward, you would think. But even there are some issues, because when it snows, it takes a while before the bubble gets isolated from the atmosphere. So depending on the rate of snow fall at the site, the little bubbles can close off in a few years, or they can close off in 100 years, and so that's a confounding issue you have to worry about. But I think that's reasonably well understood. I could be wrong. Then the other proxy is a lot harder, and that's temperature. And temperature doesn't hang around. You can get some evidence from actually measuring the temperature, but it's quite coarse. So the main temperature proxy is the oxygen-18 ratio in the ice. And when it's warmer, there's more oxygen-18 than when it's colder. I may have this reversed, but anyway, the whole point is that it's a way to estimate the past temperature. because the ocean acts a bit like a still. And, when the ocean is warmer, you evaporate more oxygen 18 than when it's cooler, like alcohol and water a little bit. So, okay. So the central question then is, if you double CO2, how much do you warm the Earth? Okay. That's called the climate sensitivity. And, people have been trying to figure that out since at least 1896, when the first paper was written by Svante Arrhenius, who was interested in the greenhouse effect and made some very credible estimates of it. And Svante's last estimate was that if you double CO2, you would warm the Earth by about 4 degrees Celsius, which is not very different from the IPCC, the Intergovernmental Panel on Climate Change. Most recent estimate, they say 3 degrees, So after all this time, a century has passed, and, countless billions of dollars have been spent, and all they've managed to do is go from 4 degrees to 3 degrees. It's going down. And I personally think, and this is an educated opinion, because I know a lot about the atmosphere, probably more than most climate scientists. I don't see how you can warm by more than 1 degree centigrade from doubling CO2. Sort of the 0th order approximation is around 1 degree C. And so the fact that the climate establishment is predicting much larger, say factor of 3, that's 300% larger than these first order estimates, 0th order estimate, because they've assumed there are huge positive feedbacks to the climate system. Usually it involves water vapor or clouds. The water vapor is by far the most important greenhouse gas. It dwarfs the effects of CO2, at least if you include clouds with the water vapor. So any little effect on, any small direct effect of CO2 on water vapor would amplify the effect. But most, that's a feedback. Most feedbacks in nature are negative. There's even something called Le Chatelier's principle, which says that, if you do something to a physical system, it will adjust in such a way to try to counter what you did to it. It's a negative feedback. And so if the climate really has positive feedback, it would be a very unusual system compared to most other natural systems. And we know of hundreds of them. The only systems I know of that have strong positive feedbacks are high explosives. If you put a little heat into an explosive, high explosive, it will run away. And so if the Earth if it had this positive feedback that's being claimed, it would have run away a long time ago, because the Earth is always being perturbed. If you leave a pile of dynamite around long enough, it will be set off, because there are always perturbations. So the idea that there are major effects from CO2, it just doesn't make any sense. It doesn't make any basic physical sense. It doesn't make any geological sense. And finally, I would say that who's worried about 1 or 2 degrees of warming? Why is that a problem? Most of that will happen in high latitudes. It will happen at night. Temperatures won't get any warmer during the middle of the day. If you look at temperature records today, all the warming has been at night, and it's been in the winter. There's been no warming at the hottest parts of the year or the hottest parts of the day. So, but most likely that will be a benefit. It will increase the growing season a little bit. It probably will increase rainfall because water vapor pressure goes up with temperature. So there's really nothing you can point to that is a threat. In fact, it's just the opposite. All of it looks good.
I think that what underlies this is the acknowledgement that the planet does seem to have periodic phase shifts. There are glaciations that happen. There are massive changes that occur on the face of the Earth. And are you familiar with the concept of dread risk?
The concept of what?
dread risk.
Spell it.
DREAD space RISK. I feel like I'm in the spelling bee. Like it's a risk assessment strategy that was developed by this guy named Georg Gigerenzer, who paid attention to the way that people freaked out about things in statistically unreasonable ways.
Uh-huh.
For example, he points to after 9/11, everybody got really freaked out and stopped flying, but they didn't stop traveling, so they started driving instead. And then he pulls up the statistics for road deaths per mile versus airplane deaths per mile, and is like, people are afraid of a one-off event, and so they start to do this other thing that's actually far more dangerous and lethal to them, because the emotionality of the fear and we seem to have an innate and inborn sense of the fact that things can go very, very wrong very, very quickly. And so we tend to overfit our worldviews to account for this awareness of things can turn aggressively at a moment's notice. And
affect a lot of people all at once, right?
Right? It's this extinction risk sensation. And so 9/11 fits into that because it feels like, okay, well, if everything's terrorism from here on out, we're all doomed and we have to be afraid of this. And climate seems like a similar thing because people look to the past and, you walk through Central Park in New York and you see the striations in the rocks. You go to Half Dome in Yosemite, you go to Seattle, and you know that there were periods of time where these places where we live and play and work and hike were under a kilometer of ice. And so there's this sensation that things can change aggressively and terribly. And I wonder if some of the climate fears aren't a transmutation of that awareness and fear onto a system that is also coupled to compassion and environmentalism, right? It's like we want to be green, we want to do the right thing for the planet, we want to not burn stuff.
Well, look, I mean, the climate is a very complicated physical system. It involves the atmosphere, a fluid. It involves the ocean, another fluid. And fluids are quite difficult to model or predict, and it also involves things like plate tectonics. If you look at much longer period changes in climate, the climate was clearly very, very different during the Permian, when there was Pangea and interiors, there's this giant continent. So the interior of the continent was probably quite dry, so everything affects climate. The time period we're living in, where we're talking about, hundreds of years, thousands of years, of course, we won't live that long, but our civilization hopefully will. There's good evidence that this has something to do with the Milankovitch cycles, the fact that, the Earth precesses, like a top every 25,000 years, whatever the exact number is. And the ellipticity of the Earth's orbit changes a little bit, because of the pull of Jupiter and other things. And so these orbital factors that Milankovitch, the Serbian physicist, first looked at probably have something to do with the cycles we're seeing the last million years or so, last few million years. There's nothing we can do about that with policy. I mean, you can't stop the precession of the Earth or, get Jupiter to stop changing the ellipticity. So for things like that, they happen very, very slowly. And I have no doubt that humanity, if it doesn't self-destruct, will be able to cope with that without any problem. There's plenty of time to adjust. And, this idea that there are tipping points, which I guess you might have been alluding to. There's no evidence of any tipping points. We've got quite good evidence of in the proxies for the last, million years, say, from ice cores, for example, and things happened over long periods of time, many centuries. The rates of change we're seeing now are not any faster than they've been in the past. And, it warmed at the end of the last glacial maximum faster than it's warming now, quite a bit faster than now. And life had no problem taking care of it, adapting to it. The biggest problem after the last glacial maximum was that human species expanded, and probably had a hand in wiping out all the megafauna that developed. Megafauna disappeared in Australia when humans showed up. Megafauna disappeared in North America when humans showed up. So humans certainly are something that historically has had a big effect on the environment and on other living things in the environment. Look what we did to the buffalo in our country, So I don't think there's any danger. I mean, if you're worried about everything, there's this wonderful Chekhov. I've forgotten Chekhov's story about the teacher who was so worried that something might happen. The man in the case. Maybe you've read it, but if you haven't, you should. But he teaches Greek and Latin in this little town in Ukraine, and he's worried about everything. He goes to school every day with galoshes and an umbrella, whether it's a bright blue day or not, because it might rain. And so this is the sort of mentality that we're dealing with here. It's certainly good to be cautious, but you can overdo it, and many people do. And so this precautionary principle, for example, is related to what you described, and it's a silly principle. It doesn't make any sense. Look, life is dangerous. None of us ever survive it. We should use the advantages that we have as humans, that we can think, and we can plan and we can react, and not every animal can do that, but we can do that, but not all of us do it. A lot of us are completely governed by emotions, and, you think you understand something, but you don't really understand it. It's just an emotion, So it's a real worry. We talked maybe, Dietrich Bonhoeffer had this wonderful insight, what happened to Germany in the 30s, when this country of poets and philosophers and musicians, what a wonderful country was taken over by thugs, just awful people. How is that possible? And was it evil? And Bonhoeffer said, no, I've thought a lot about this. It's really stupidity. Dummheit was the word he used in German. Dummheit, dumbness. And his argument was that if there are enough dumb people in any society, it makes it possible for thugs like the Nazis to take over. And I think we should pay attention to that theory. That's certainly something that happens. And I think, again, I'm talking about things I don't know very much about. I know a lot about differential equations and how to measure CO2 or temperature or things like that, but I really don't understand humans. I've never claimed to understand them, but it seems to me that one thing that's missing is that people need meaning in their lives, and lots of people have no meaning in their life. And it doesn't have to be, that I'm going to be a Nobel Prize winner in medicine or physics or something like that. It's that I'm living a meaningful life in some way. If we could somehow give young people the opportunity to feel like they're having a meaningful life, I think it would it would solve lots and lots of problems in the world. I don't know how to do that. And, I think many people have noticed that this is very hard to do. But we've tried. For example, the Peace Corps was something a little bit like that. It was to try to give young people something important to do that really was useful. It sort of withered away. I'm sorry. I guess it still exists, but it's not very important for most young people. It's unusual to join the Peace Corps. But instead, we're taken over by all of these fears, unrational fears, about climate or God knows what, overpopulation and.
I think it's marketed as a way to make people feel like their choices are meaningful, particularly as consumers, right? They can have some contribution to an overall positive by doing what they already do, which is buy stuff, but maybe buy better, air quotes stuff. By the way, we lost your head again.
Lost my head. Okay.
Never ending.
I'm gonna have to fix this camera so it doesn't jump around. All right.
I think you're onto something about the consumerist nature of it, because the most threatening thing would be
Like you
if
can buy your identity. That's sort of the what is it? The Freud nephew, Bernays, right? The Edward Bernays idea that you can sell people an identity, right? And it's, of course, people's ability to identify with these causes and with the products that they buy is really still at the heart of a lot of this decision making. It's like you don't have to maybe necessarily like make yourself into something so much as join a cause that will give you some meaning, but that kind of meaning that you join, when you join onto some meaning, it's far less meaningful than if you actually construct a reality of your own.
Yeah. But that's the point I was trying to make. Is I think take someone like Greta Thunberg. She needs some meaning in her life, and what could be more meaningful than to save the planet? And so she's, this is not a bad motive. She's mistaken. But the motivation you can understand. Everybody wants to do something meaningful in life. And so the question is how to prevent this from being distorted into crazy things. It's sort of like autoimmune, responses. You get a bee sting and you die not because of the bee, but because your immune system kills you, right? And so there's something like autoimmune diseases in human society that come from time to time, and we should figure out how to stop that. I don't know how to stop it. People have been trying to do it for millennia, and smarter than me, people who understand the human nature a lot better than I do.
Well, I think there's something really important about, like, there's a really important corollary between how difficult something is and how meaningful it is. And there's something very easy about signing on to a pre-existing cause or something global that's ineffable and, in some sense, yes, huge impact, but also very distant in terms of your ability to affect it. And there's something very, even the smallest changes that you make in your life that would actually be contributing to your overall sense of meaning, like getting up earlier, working out, eating more, carefully. These are really, really meaningful choices, but they're very difficult and they don't seem to have this global impact that people are going to acknowledge you for necessarily, especially on the short term. Like nobody's going to care that I got up and did a bunch of workout, that I did a bunch of exercise this morning. Nobody knows, nobody cares, but it's very meaningful at the same time. And there's something about how meaning really arises in this private sphere of what you're doing in your local habitat that it just isn't visible on that same level. You can't signal it in the same way. It doesn't get you any social credit in the same way that if you support an existing movement, you can just sign on to and be part of that. And all of a sudden you have really a family of people who are all part of that together. I think that's what we're up against.
Put your finger on it, Michael. That's completely true. And I can't add to that.
I do want to add something to that, because I think that you're absolutely correct. But there's a marketing question here, right? So while you guys are talking, I'm trying to find a chart that shows the correlation between ice ages and carbon dioxide levels. And it's surprisingly difficult to find when you just go to Google because everything cuts off at about 650,000 years ago for decent data. And there's probably good
Well,
reasons for
that's time enough for four, glacial maxima, roughly.
Sure. And so but the thing is, in those charts is that the most frightening aspect of the current climate conversation is the fact that when you look at the chart of carbon dioxide levels, you see the hockey stick shape with the beginning of the Industrial Revolution. And that gives people the sense, it's a marketing presentation, because if you were to extend the window of time, you would see that this level of carbon dioxide is not anomalous in context of the history of the planet. And in fact, in context of the history of the planet, it's actually quite low, right? But
That's correct.
when you see the last 10 glaciation cycles or the last 4 glaciation cycles, let's say over the last 600,000 years, our current level of carbon dioxide is much, much higher than it's been over the course of the last 650,000 years as looked at inside of the ice cores. In fact, it's almost double. And so I think that that's the basis that's being used to really freak people out. And I wonder if you have an analysis of why that level is so high. Is that a real measurement? Is that a meaningless measurement? Are we just part of a planetary cycle where it's rising? Is it good that it's rising? Is it bad that it's rising? Is this even something we should be paying attention to? Like, where do you fall on the hockey stick graph?
Well, the hockey stick really doesn't refer to CO2. It refers to temperature. So the Michael Mann hockey stick was where you plot temperature versus time, not CO2 versus time. You were supposed to infer that the temperature rise was caused by CO2. And the point of the hockey stick wasn't so much the blade of the stick where it was going up, temperature was going up. It was the fact that there was no medieval warming. So all of the previous ups and downs of temperature that had been known for a century and well documented suddenly disappeared, So the fundamental problem with that is that it certainly looks like fabrication of data, So it's the main handle of the hockey stick that's the problem. It's not the blade going up. But as for going up in CO2 concentration, there's nothing about that that's dangerous or bad. It's good for the world. If you go to any commercial greenhouse, especially in Europe, but in Canada and places like that, the greenhouse operator injects CO2. So inside the greenhouse, it's 3 or 4 times what it is in the outside air. And that's not cheap. He has to pay for the CO2. So he wouldn't do that if there weren't some benefit. And there's a huge benefit because the plants grow better, you get better quality tomatoes, you get better quality flowers to put in the market and stuff like that if you have 3 times the CO2 of outside air. And there's even more benefit on the outside. If you go outside of a greenhouse, you can measure chlorophyll, which we do from satellites, and the whole world is greening everywhere you look, especially in arid regions. The world is greener than it was 40 years ago when satellite started measuring. And
that's a pretty cool mechanism from what I understand, because in these arid regions, you're really, as a plant, fighting against evaporation. Like you have to open your mouth to breathe, something like
that's
that.
right.
And in doing so, you're losing a lot of water. And so if the
That's right.
CO2 is
Yeah.
higher, you don't have to open your mouth as wide, and they're
Yeah,
able to retain
that's
a lot more
exactly
moisture.
right. That's exactly right.
It's
So
really
more
fascinating.
CO2 increases the water efficiency of plants because they don't transpire as much. That's the main reason. But inside a greenhouse, that's not the reason. Inside the greenhouse, there's plenty of water. Doesn't cost you anything to add water. There, it's a more subtle thing. It's because the photosynthesis uses a enzyme called Rubisco. It's a big, complicated name, but it was invented 3.5 billion years ago, maybe longer, at the beginning of life when there was very little oxygen around. And so this enzyme, which is the most abundant protein in the world, because it's in all green plants, is poisoned by oxygen. And so in our current atmosphere with all this oxygen, plants are struggling to reduce the toxicity of oxygen. So any plant is full of detoxification mechanisms that get rid of the nasty products that the Rubisco makes from oxygen. When Rubisco, this enzyme, can't find a CO2, which it has a hard time at low levels like we have today, it will grab an oxygen instead, and it converts the oxygen into things like, hydrogen peroxide or ammonia, rather than sugar, which is good for the plant. But, it's not good to have hydrogen peroxide inside you if you're a plant, So they've got all sort of antioxidants and things to control this photorespiration, is what it's called. The fact that light makes the Rubisco create toxic products inside you. So that's what's being controlled in the greenhouse, because if you have 3 times as much CO2, that means 3 times less oxygen is mistaken and converted into hydrogen peroxide and all these other nasty things that damage the plant. So there are 2 major effects of more CO2. Drought resistant, which is the main one outside of a greenhouse, and inside of a greenhouse, it's photorespiration suppression, because there's more CO2, there's less photorespiration. But both of those are really good for life, what's to complain about? And that's what plants are adapted to. Plants evolved when CO2 levels were much higher than they are now. So they're struggling now. There's a class of plants, like, there are not too many of them, but some of them are important. Sugarcane and corn, for example, use something called a C4 photosynthetic path. And that's designed to cope with this photorespiration problem that we just have been talking about. So they're able to protect the Rubisco that's from the oxygen in the air by putting it in fiber bundle sheaths and transporting in the CO2 without bringing in oxygen. And so they have a competitive advantage today compared to most other plants, all forest trees, for example, wheat, soybeans, are all the old-fashioned photosynthetic thing that's poisoned. But corn and sugarcane are immune. And anyway, there's a lot to talk about here. It's very interesting stuff, and you can.
There's a real interesting irony there in this climate disaster that is, often called the fight against the climate change is called the green movement often, and it's very ironic that the Earth has greened so much in the last, I don't know, couple decades. I mean, there's some numbers flying around. Some enormous area of land has been greened in the past 2 decades. Unprecedented.
What's really crazy, though, is the land has greened, but I don't know if you've been looking at the photographs that NASA puts out. The photographs of the Earth that NASA puts out are browner than they were in the 90s. Like, the actual color of the continents looks more arid.
Probably PR.
It's like one of the weirdest.
Anything you like, but if you look at the chlorophyll fraction, which is what they normally show, that's clearly increasing, all over the world, especially in arid regions. That's where you got the biggest advantage. That's kind of interesting too, because what you do is you look at the fluorescence of chlorophyll in sunlight. About 1% of the photons that the chlorophyll captures are actually not used to make ATP. Instead, they're used to they're converted to near infrared light that comes back out. And so the idea is, if you look at this fluorescence, that tells you how much chlorophyll there is. Not many other things fluoresce on Earth. Chlorophyll is one. But
Will,
that's
we've
hard to
lost our
see
camera
because you're
again.
looking at it at the background of the sun. The sun has got huge amounts of radiation at that same wavelength, 100 times as much. And so you can't see it. And so the trick is that you look in the Fraunhofer lines of the sun where it's dark. And so these gadgets on the satellites are a beautiful design. They look only in the dark lines of the sun, and there you can see the fluorescence clearly because there is no solar background to worry about. So it's a very clever trick. And,
We've lost your head again. I'm sorry.
lost my head. Okay, yeah.
There we go.
You can tell when I'm excited, you lose my head. I lose my head.
I mean, it's so astonishing to me because I feel like the vilification of carbon dioxide is because it's industrially convenient to vilify. You can build scrubbers, you can build mitigations, you can build a carbon tax, you can build a carbon credit, you can trade things, you can move things around, and you don't have to change that much. You don't have to change the fact that you're dumping cancer-causing chemicals in the Louisiana bayou because the salt dome in which you're storing your petrochemical byproducts implodes and causes a sinkhole and destroys a century-old community. Like you don't have to change the material foundations of everything that is dirty about what we do.
Not only that, but you can stimulate the industry from an economic standpoint, right? You can subsidize all of these technical updates and so forth.
Yeah, and it's just a strange thing that people seem to be so captured by it. I think that there's a lot to be done to make the planet habitable. I think that there's a lot of dirty industry. I think that there's a lot of chemistry that goes into our environment that we have no idea what it's doing to the biome. But we don't talk about that as much as we talk about CO2. And that's the thing that really perplexes me because these people are smart. They're not stupid. They're scientists, they're PhDs, they're well trained, but there's almost no analysis that goes beyond CO2 is bad, we must mitigate CO2.
Well, you're right that we should be against real pollution. I'm certainly against it. And, we've done a lot there. When I was at Columbia, where you guys were one time, the Hudson River was an open sewer. You'd look into the river and you could see just feces, floating down the river. And now when I go back to Columbia, it's pretty nice. You can go swimming there. They've cleaned it up enormously. And so we've done a lot of good for the environment, even in my own lifetime. I've witnessed this. And, when I was a kid, I'm an immigrant. My father was Scottish, so I went to school in Edinburgh. And at that time in the late 40s, we used coal, and the whole city was full of coal smoke. I'd go to school in the morning. When I'd come home, my white collar was all black, from the coal smoke that had sifted down. And yeah, and people didn't pay any attention to it, but it certainly wasn't good for them. There were lots of lung diseases and lots of unnecessary illness that was due to that. That's been cleaned up. Edinburgh is a beautiful city now. So almost any measure that you can take of our environment has gotten better, in my lifetime. I can't think of any that's gone the other way. So that's why I have a really hard time understanding what is the concern. Of course we have to watch the environment, but and we're actually making it better. And so, if you invent non-existent threats, that means that you're ignoring real threats that need to be addressed. I think that was part of the point that you were making there. It's really hard to cast CO2 as a pollutant because, each of us breathes out 2 pounds of CO2 a day. We're CO2 emitters. Does that mean that we're polluters? Of course not. It's just like breathing out water vapor. Water vapor also is not a pollutant, but you have to breathe it out because part of your metabolism, you know.
Mm.
So uh, it's frustrating that, again, it comes back to Bonhoeffer's Dummheit, you know.
Yeah, I was gonna go back to that. I'm curious if you think that anything could have been done, right? Is there a way that the German people could have been less dumb? Is there can we look to the failures of the academic structures for the dumbing of America? Like, where is this coming from? Is there I mean, I have some of my own ideas about the university structure, but I'm curious if you think that this is something preventable. Can it be can we wise up as a population?
Well, I don't know. You know, I think there were special conditions in Germany because, you know, they had lost World War One. They had gone through, you know, a decade of hyperinflation. You know, lots of decent, innocent people had been badly hurt, and so it was a society that was already badly wounded. And you know, our Western societies today are not nearly like Germany in 1930. You know, so
Not yet.
I think it'll be easier for us to correct things peacefully than it was for the Germans. I'm not excusing them, but and certainly Bonhoeffer did not. He and he paid a heavy price. You know, they hung him.
Yikes.
Um, I don't know. You know, we did something sort of like this during Prohibition. We 1919 or 1920, I've forgotten when, we passed this Prohibition amendment to ban alcohol. And there were a few timid voices who said, you know, maybe this isn't a good idea. It could encourage organized crime. It'd be hard to enforce, you know, might make people contemptuous of the government, you know. Of course, they didn't get it nearly as bad as it turned out to be. So it's the only amendment that we ever repealed, you know, but it took us 15 years to realize what a disastrous mistake we had made. And so, but nevertheless, it was done peacefully. You know, there was a lot of terrible things that happened. It got organized crime going. In fact, you know, the drug problem we're having today, part of that started in Prohibition. You know, it's the same families running it. And so there are long-term fallouts, bad fallouts. If you do stupid things, it takes a long time to correct them. So I hope we won't go too far on this one. It could turn out that it'll end like Prohibition. You know, people will finally just say to hell with it. You know, this was clearly a mistake. But Prohibition, you know, all the best people were on the side of Prohibition. You know, you couldn't speak against it. Otherwise, you were in league with demon rum, and there were all these poor orphans and widows whose father had drunk himself to death, you know, on demon liquor. And so it's a little bit like climate, you know, you're murdering the planet. How dare you speak out against this? And so,
Which is really ironic too, because you could just not drink too, right? Like if individuals just took that responsibility on themselves,
yeah,
it's strange that you would look to some father figure to restrict your access to it, as opposed to just being like, hey, it's like telling your wife to hide the liquor bottle because you drink too much. It's just a little bit
right.
perplexing. And but do you think that America is getting dumber? Do you think that that's contributing to this?
Hold on. I would like this dumber idea. I don't think is totally accurate. I don't think that it's stupidity. I think that it's emotionality. It's being driven by your emotions.
But I think there is some dumbing actually, and I think that I know why.
Okay, all right, lay it.
Well, I just the way that I see the university structure going is that
Mm.
it's increasingly look, I
Are we
work.
gonna get fired for
Yeah, I'm
this?
gonna get fired for talking about this probably, but that's okay.
We both teach at a university that's nearby, and we've both have discovered the same frustrating aspects of it.
I mean, the frustrating aspect is that there's increasingly less money going to the education and increasingly more money going to this just absolute proliferation of the bureaucracy behind it. And it's not a small problem. It's to the point that the university professors are getting paid peanuts. It's basically like no one in their right mind would become a professional teacher in a university at this point, which is tragic because in some sense you want to have the best minds at the university teaching the next generation. And so there's this brain drain from the university structures to the point. I mean, fortunately, we do a lot of other things so we can make time to teach a class a week or something. But how long can we even sustain that for? It just doesn't economically make sense. And so I worry that as opposed to a situation where, because look, universities will take in, a lot of universities will just take students in because they can pay for it, right? They're not taking the best students as much anymore. They're taking the students that can afford to go there. And they don't really even care. I mean, the graduation rate at some of these universities, including our own, is just abysmal. It's like they don't really care whether these students succeed or not. They're just looking at that bottom line. And honestly, a lot of these universities operate essentially as hedge funds at this point. And so I really worry that this bureaucratic corruption at the university scale is leading to some of this dumbing down. Because you say, like, oh, they're intelligent scientists and stuff that are coming out of these universities. And I just worry that if they're not in the universities because they're selected on a purely meritocratic basis, that maybe they're not the smartest scientists. Maybe they're just the ones who could afford to suffer through the arduous financial burden of making it in and out of the university structure. Not to mention the just brain drain of the professors that they're going to be exposed to.
If I can add to that, there seems like a big transition in terms of how science is done and the way that people are interested in the sciences. Like I'm reading Faraday's biography right now, and Faraday ended up in the Royal Institution because he was the most curious and the most interested in chemistry and then eventually in electromagnetism. This was a guy who just had some muse whispering in his ear that this was what he was going to do. And there's so few, I'm sure that there's students that are still like that, but the university system has become a means to an end. It is, I will get my degree, the degree certifies me, I will take my degree and I will go do something else, or I will fit into some kind of hierarchy. And this notion of I will work independently and discover some unknown phenomena is kind of in this distant background where it's relegated to something that people used to do in merry old England or something.
Yeah, Faraday's an interesting example. He was hired by Humphrey Davy, who was a very distinguished chemist, from a wealthy family. Faraday's family was quite poor, there were some religious sect there, and but Faraday was always just fascinated by science, and he had very poor training. He didn't know any mathematics, but he had just incredible intuition about how the world worked. So it's interesting to read Maxwell's commentary on Faraday. Maxwell basically used his erudition, his complete familiarity with calculus of multivariables to turn Faraday's ideas into modern electromagnetic theory. And one thing you can see there is that in those days, in the 1800s, you mostly were either wealthy or you were an assistant to some wealthy person if you did science. There was not much government funding. Certainly the Royal Society didn't provide very much money. So it's only in the 1900s and kind of late in the 1920, 1930, that government money started to come, and especially after World War II, that's when the gates really opened in terms of government funding. But maybe another part of the problem is that there's only a small fraction of the population that really would benefit from the type of university education that we hold dear. And we're probably trying to force too many people to go to universities who would be more productive and have better lives if they didn't. They might go to some other type of training school, but the sort of the traditional liberal arts education is really not meant for everyone. They should have a good fundamental education, but there's no reason everyone has to read the great books and, be familiar with Plato's Republic or, or, whatever, So I think that, as Michael said, it's become kind of a cash cow for an industry. And the, administrators is a big problem too. It goes with the money, because if you're getting money from the government has to keep tabs on how you're spending it. So it's part of that government financing of education that has come with it. I read recently that nowadays at Harvard there are more administrators than there are students, and that it's probably true at Princeton too. I'm not sure. I haven't checked, but everywhere I look, there's an administrator, and I walk down the halls and I very rarely see another faculty member. And I don't see all that many students either. Right? So the majority of people who walk around my building are administrators. They're very nice people. I like them and they help me, but I'm puzzled, what's happened to the university. Yeah.
Yeah, somebody at MIT the other day told us that it was like a 1-to-1 ratio. There's one administrator for every single student, something like
Yeah.
that, which is pretty incredible. I mean, we had this kind of wonderful opportunity very briefly after grad school. We worked in the high schools up in Portland, and it was just so eye-opening because this paradigm starts at such a young age. There's this dream still very much alive in the high schools that every student goes to college. And it's very perplexing because there's this other complete crisis in the high schools, which is a good portion of the kids don't want to be learning calculus, and they're not interested in those sorts of intellectual pursuits, and they ruin the entire classroom for everybody else. And so the way that they deal with them is they essentially imprison them at the high school. They have like essentially a security department, and they'll come and escort these people away. And it's just really tragic because if you pull up, like Anastasia had the opportunity that she pulled aside one of these troublemaker kids one time, and he was like, maybe I'll let you tell the story, but he was essentially said something to the effect of, well, I know I'm going to work on cars after high school. I don't care about this stuff. And it was it just was this real deep heartbreak feeling of, oh my gosh, this is a really passionate person, and they just don't fit into this structure, which is essentially funneling people towards these colleges where they're probably going to fail out anyways, but the college gets their paycheck. And it's one of these things where the compassion, like the teachers thinking, oh, you got to go to college so that you can have a good life. Like they really believe that they're doing the right thing, but it's somehow become corrupted in this very predictable fashion that we see over and over and over again, all the way up through the climate narrative. People want to do the right thing. And the same thing happened during COVID. People want to do the right thing, but instead they're just feeding this furnace that's really is this terrible feedback loop.
Yeah, I think it's one of the curses of our modern society that everyone is supposed to be the same, and it's just obvious that everyone isn't the same. And some people are talented in music, some people are good at sport, some people are good at math. There are all sorts of things that you can be good at, and we ought to value anything that someone can excel at. That's good for society. I don't know, Martin Luther commented on this, and he says, you don't have to be a theologian, to praise God. A cobbler who makes good boots is praising God with his boots. And so I think, that's the sort of thought that there are lots of ways that you can contribute to making the world a good place. And going to college is not necessary. It's obviously not necessary. And we ought to make it easier for that idea to take hold and to make sure there's no stigma attached to it, because you feel like you're sort of a second-class citizen if you don't have a college degree, but really you're not on any really objective assessment of it. You're often a more useful citizen than the guy who has 2 or 3 degrees from college, because you're doing something useful. You may be a good roofer of a house, or a good auto mechanic, or whatever. A good nurse,
It's strange to think that the solution to that might be roping in the privatization of the universities in some sense, because if you look at like the University of California system, it was very meritocratic in the beginning in terms, and they were very, very at prestigious universities that were essentially funded by the state exclusively. And it makes sense that when the state's operating universities, that they'd be more interested in getting the best students in there with the best professors, which is strange because I don't generally favor the state taking over industries. It's usually a disaster, but it seems with education, in some sense, the privatization has run away with this incentive structure in a way that I don't think would happen if the universities were run by the state.
Yeah, maybe so, but it does bring to mind the idea of elite institutions. For example, in New York City, I'm sure you noticed there were these kids from Bronx High or from Stuyvesant who really had fantastic educations. Their instructors in high school were like you two in Portland, and yet they stayed for a whole career and educated lots of good students. And so good high school teaching can make a difference, but only for a select number of students, so you can't just sign up to go into Bronx High. You have to take an entrance exam or Stuyvesant. And so a small number are selected, but then there's a really good impedance match. They've got good professors and they're good students, and good things happen. If you look at the Nobel Prizes awarded, say, in physics, it's astonishing how many originated at Bronx High or at Stuyvesant, just because they picked these talented, hardworking, first generation immigrant kids, and they gave them a chance, and they went on to do great things. My own, I have an American family from North Carolina, and my son teaches at a North Carolina school for science and mathematics, where it's a boarding school, a little bit like Bronx High or Stuyvesant, and people all over North Carolina, it's a rural state still in many parts, they can send a student to this science and math high school, and they board there, and they get the same sort of teaching that Bronx High and Stuyvesant used to give in New York City. So that's a model that clearly works. I remember once asking Edward Teller, how is it possible that the small number of brilliant people, yourself, John von Neumann, Eugene Wigner, Szilard, all came from this little school in Budapest. They're all Hungarians. And Teller says, oh, very easy. We had a good high school teacher of physics. And so, good teachers really make a difference. Here was a case where whoever that guy was, if anyone deserves a Nobel Prize, it was whoever taught that galaxy of people who came out of Budapest, in the 20s.
That's so interesting that you say that, because I've been thinking about that in context of art. Like, we play music, and we live in a town where the music scene is decidedly not of our type and interest. It's like gothy metal bands, I would describe it as. And I've just been thinking a lot about the most successful artists that I know, and they all came out of schools of thought. And I think that science works the same way, where you go to a place and it nucleates your ability to play with ideas, and it opens up your imagination, and people are pushing each other towards some kind of unexpected innovation, whether it's the impressionists pushing each other to do with paint what had never been done before, or modern musicians in Berlin discovering what, house music sounds like for the first time. It's a group of people that are able to convene over their fascination for what comes next in any field. And I think that might be what's missing now, where there aren't these little pockets of people, because it's such a mixed world, right? If you're part of
There's the feeling that a college degree is a college degree, like just the degree itself is the same.
And it is, but I'm like, people are living longer, so like the college degree is the college degree. That's fine, but if you're part of like the American Physical Society, how many people are part of the American Physical Society? Like,
membership. I don't know what it is now.
but it has to be like tens of thousands of
Yeah.
people, and so it's not like that's a place where you have a small group where everybody knows each other and you're exchanging these breathtaking ideas. It's just kind of the soup that you enter into, and the soup is homogenous, and you have to there's a culture of what ideas can be shared and what ideas can't be shared. And I think that it can really be solved by billionaires funding enclaves. Like that's the only solution that I can see, right? Because we know that back in the day, it was independently wealthy people that were scientifically curious that were able to do these sorts of things and build up these societies. And so it makes perfect sense that if Jeff Bezos does not seem like he's got a lot of questions about biology or atomic theory. But he does seem like somebody who would be able to, with some small fraction of his wealth, create a condition where people who were curious about it could spend all of their free time outside of the academic system focusing on it. And I wonder if you know of any people that are working on developing these sorts of programs, or somebody who's
Is
interested.
there like an equivalent for Bronx High in the sciences? Are there going to be more of those sorts of private niche enclaves of education popping up in the future?
Well, it's a good question because, if you read about Britain in the 1800s, there were little societies, learned societies in quite small towns. It wasn't just London, Birmingham, Nottingham, they all had scientific societies, and it might have been 24 people, but they would get together every month. I don't know exactly what the schedule was, but they would present work that they were doing to their comrades, and it was very informal. It wasn't run by the government at all. But many people got their start that way. One who comes to mind is George Green, of Green's Functions, and he was from Nottingham, but his work was really first developed for one of these little local societies, and it was promoted by people in those societies. Some rich person there actually published some of Green's work, which was just groundbreaking. It still influences physics to this day, but it was because of these local things, and so maybe that can happen again. I don't see that happening here in Princeton. I think part of our problem now is that we're so well connected through these computer screens, and we can look at the internet, that we don't crave this human interaction that we used to have person to person, 50 years ago or 100 years ago. So I think the computer revolution, and it's actually been damaging to some extent, in that it has dampened these interpersonal relationships that used to be so important. And
Yeah, and what's the way back from that? Do you seem to have a lot of optimism, which I appreciate. I'm curious if you have a crystal ball on the future with respect to, renucleating that human interaction. Do you think that people will become more willing to travel to local places to interact with these communities, or
Well, not if they can't fly on airplanes.
well, whoever was said, predictions is hard, especially for the future. As well as I do what's going to happen in the future. But I am optimistic. I think that most humans, if they're given a chance, and if they're not corrupted, they're pretty good creatures, and they're easily corrupted, though. I mean, just look at what's happening now in Palestine. It's just your heart sinks. How could this happen in the modern world? And so the question is how to prevent this evil that infects the human species from time to time. I'm not going to say who's evil or who's not in this case, but it's clear that we've got this ancient problem that you can read about throughout history, that you would hope maybe there's some way for technology to make it better. I don't see quite how to do it, but maybe there is some way. But
Yeah, it's
I
like
think
it's
it's
like
really
a wound that won't heal.
Yeah, and also I think the hope comes in understanding the coupled incentive structures. I mean, it seems like this war in the Middle East has been really good for gas prices out here. I don't know about where you're at, but as long as those kind of things persist, I feel like there's no way around finding ourselves in these perpetual conflicts. As long as it's good for somebody somewhere, it's not going to be a solvable issue.
That's right. Cui bono, they say in the law. Whose benefit will it be?
Mm.
And there usually is somebody who's benefiting when these horrible things happen, not the poor people who are involved in it. Yeah,
Yeah.
yeah,
No, it's devastating because you hope eternally that there's a time where we will be able to talk about things and work through them and abandon this emotional desire to inflict revenge and to punish when something bad happens to us. And sometimes I see glimmers of hope that people are able to do that and to recognize that it's a cyclic process, that if you can't break it, no one can break it. And other times I become I vacillate between great hope and great disappointment. But I do think that this is the era that we live in, which it's our obligation to find ways to talk about things. And we've gone through the age of reason, and we've gone through the age of enlightenment, and we've gone through the age of atomics and all of these other things. And I feel like the precipice of the age that we are on is the age of emotionality, or of controlling our emotions, of learning to talk through the things that evoke in us the most primal, fear-based sensations. And that's what's happening in Palestine right now. It's the manifestation of man's worst terror and worst impulses in response to a wound. And I see that same action playing out to a much, much smaller degree in the sciences too, where people organize around positions and they reinforce those positions and they wage an ideological war on the basis of what they believe in and the wrongs that they feel have been inflicted on their side. And so I think that there's a chance for it to change, but there's no top-down mechanism for it. It has to become a cultural touchstone that people take within themselves to say, no, I will seek what is right, despite the chaos that surrounds me. And I feel like you've done that over the course of your career. And I really appreciate that. I really
well, thank
value
you.
that.
Thank you. Well, since history began, people have been struggling with these ideas. These long predate modern science. The wonderful thing about modern science is that it really can be verified from nature itself. There is an absolute scientific truth. It's not, when people talk about the consensus about science, that's of course nonsense. Science is about things that you can verify from experiment and observation. And so that's still true, and we're lucky to have that in spite of a few, out of tune voices who don't appreciate exactly how it works. But I guess that's why I've always liked science, because when I get fed up with mankind, I can always go, look at the Pythagorean theorem or Cauchy's theorem or, Kepler's orbits, and they're so beautiful. And, it's just amazing that the world is put together in a way that you can understand it. One of the Hungarians I mentioned, Eugene Wigner, taught me quantum mechanics here at Princeton, and he wrote a nice article. Maybe you've seen it, but it's called something like the unreasonable effectiveness of mathematics in the natural sciences, or something like that. It's a famous article. But when you think about it, it really is astonishing that the world we live in can be explained so beautifully. That the Planck function, you can actually measure it. What you calculate is what you measure. The parts per thousand, and other things are parts in 100 million. There are these wonderful simplicities that characterize our world, and they don't characterize us. Unfortunately, we're a lot more complicated. But when you get discouraged, you can always go back and look at these fundamental things, which are beautiful.
And there's always this, once you've observed some scientific truth, I think there's, regardless of what the consensus feels about it, I think there's always this feeling in the back of your head, like, it'll be okay because people will figure this out eventually. Like, you can't hide from the truth forever. It will eventually rear its head in one way or another, and it's just, in some sense, a matter of waiting out the opposition.
I hope that's right. Yeah, that's often worked in the past, although there are societies that become stagnant for a long time, and it takes but they eventually succumb to change. And I think institutions tend to get corrupt. I think it's important there be some way to shake up institutions from time to time, hopefully in a peaceful way. But even institutions I've seen in my own lifetime, they tend to get they tend to go bad. Part of the problem is, to run an institution, you have to have people who are willing to put aside other things that are more interesting, and therefore they tend to get staffed up by people who are not, if it's a scientific institution, they get staffed up by people who really didn't like doing the science very much, but they can be a science administrator. And so that tends to drive these institutions in the wrong direction. They're run by people who really don't like the the central focus of the institution. They don't like chemistry, they don't like physics, but they like administering it. Yeah.
Yeah,
And they're very effective at growing them too, which is interesting.
Yeah. I mean, we've been talking for almost 3 hours, and I feel like we've taken a lot of your time. It doesn't seem like we're anywhere near the bottom of what we could talk about, but
Yeah, before you leave, can you recommend anybody that you think we should talk to fill out this conversation even further? Is there anybody that pops into your mind?
Someone I have a lot of respect for is in the climate area is Patrick Moore. Have you talked to Patrick? Patrick is one of the founders of Greenpeace Canada, and he lives on an island in Vancouver Straits, and he was one of these people who put his lives on the line, opposing the killing of whales and opposing nuclear tests. But then Greenpeace, as all institutions do, eventually went to seed, and then he quit, because they had sort of run out of worthwhile things to do, and so they were now mounting these crazy campaigns against, for example, chlorine. That's when he quit, because supposedly chlorinated water was ruining the world. In fact, it's it's the thing that reduced infant mortality, because you've got finally you've got water that's not contaminated with cholera or typhoid. But Patrick would be a good guy to talk to.
Yeah, we've actually had him on the show. We had a long conversation.
Good.
In some senses, it was very good. In some senses, it was very frustrating, because Patrick was very all or nothing about his assertions regarding the physical universe. It was difficult, especially when we got into the micropollutants and so forth. And then, of course, people will always accuse him of being a shill for the different industries that he's been associated with, and so that makes I think, in some sense, for the audience, that weakens his position.
But he was very gracious. He spent 3 hours with us in conversation, and it was a very lively conversation. So that was covered it.
Someone you might consider talking about on climate is Steve Koonin, if you haven't already. But Steve is 10 years younger than me, and but sort of went through the same change of thoughts that I did, having served in DOE and watching what was really happening in science. And he wrote this book, very nice book recently called Unsettled.
Mm-hmm.
And so he would give a good talk. You would enjoy talking to him. He was provost at Caltech for a long time, so he's been an administrator himself. And but he's a good physicist. He's a nuclear theorist by training.
He's a hard man to get a hold of. So if you happen to run into him, put in a good word for us.
Yeah, I can tell him to answer the phone next time you call.
Fantastic, thank you.
He probably will. Yeah.
That'd be great.
But yeah, it's been really great to meet you. I really appreciate you giving us your time, and I'm excited to tell my students
Well,
that
I appreciate what you
talked
and
with you.
Anastasia are doing. It's important, and I don't know how big your audience is, but
Bigger every day.
It's getting bigger. I hope it should get bigger. But this sort of a short attention span life that we live is really not good for for society, because everything is superficial, and you have one of the few non-superficial, venues that I know of. I mean, I've listened to 2 or 3 of them. It's a big investment of time. Most people don't have 3 hours to watch a video, but I found it worthwhile. And
I really appreciate that.
yeah,
I appreciate that. I mean, one thing we've had a lot of success with just cutting out really small moments from these conversations, and those little short videos will get passed around, and in an afternoon we'll do thousands and thousands of views on them. So
I see.
and the hope is that those will lead people to the bigger conversations. I don't know if that's the case, but there does seem to be a way that the ideas can be extracted from these conversations in a way that's palatable to the modern short attention span. So I'm hopeful about that.
And I think people are hungry for these conversations. Like you mentioned Rogan at the conversation with Rogan and Musk. And Rogan's the biggest podcast in the world pretty much every week. Among women, men, I think even teenagers listen to it. It's a place where people can sit and have ideas at length. And I think that people are really, really, really hungry for that. Which is why I don't think that people are getting dumber. I really do think that people want the opportunity. And they just don't want the opportunity in context of the kind of nanny state that is the college class. They want freedom to explore ideas and to not have somebody tell them, "Oh, you can't think that."
I was interested, as I wrote you, with your family name. Do you pronounce it Shiloh or Shiloh? Or
Shiloh, yeah, it's my middle
Shiloh,
name.
you pronounce it. Okay, yeah, because I was so struck by, what it meant in Russian, and so what is your background? Where are you both from originally? Your parents from?
Well, Anastasia is Russian. My family is Appalachian and Norwegian. So
Okay.
yeah, the naming comes from Appalachia, except for the first name.
Yeah, I was born in Chechnya. I was born in Grozny.
Where?
In Grozny.
Grozhensk.
No, in Grozny, in Chechnya.
Oh, in Grozny. Oh, okay.
And then my family immigrated
in Chechnya.
Yeah. Do you speak Russian?
Немножко. Вы тоже?
Да, мы дома говорим.
Ну, хорошо. Ваши родители еще в живых?
Да. Они рядом с Сан-Франциско живут.
San Francisco.
Yeah, so my family is down in San Francisco, and we've always spoken Russian at home. Like a lot of my parents' contemporaries, they came here and they lost the language immediately because their kids went to school and they started learning English, and they kind of all transitioned to it at home. But my mom literally would not speak to us if we didn't speak Russian. And my brother, who was born in Canada, actually fluently reads and writes Russian to the degree that he's, every other novel that he reads in Russian.
I see. Interesting.
And so it's an enormous credit to them that they've maintained the language. Shiloh's learning it slowly.
I'm learning to read mostly.
Oh, yeah, good for
my
you.
speaking is abominable.
But is Shiloh your own name?
Shiloh, yeah, that's my middle name.
Shiloh is
Yeah,
your
that's
middle
kind of
name.
what I go by. Yeah, Michael is
Shiloh.
kind of a mouthful, but
I
yeah,
see.
In Russian, we call him
But it was
Shiloh.
like the Shiloh of the Bible or something like that.
exactly. Yeah,
That Shiloh, yeah. Because we usually, I think, like the Battle of Shiloh, it's spelled a different way. I think Shiloh or something
yep.
like that.
hmm
Yeah, yeah. I see. What part of Appalachia are you from?
Like the Ohio River Valley, right there on the river. That's where all my dad's family's from for
I
generations
see.
and
Okay.
generations.
Yeah. Yeah. My mom's family is Appalachian too. Yeah. So they
Yeah, it's
were.
really sad. We lost my grandma died, and we kind of lost our connection to that part of the world.
Uh-huh.
It's really tragic because it was such a rich culture. I just loved going down there as a kid. It was just totally different than the suburbs where I was living.
Yeah.
And
Southern Appalachian's a nice place, actually. It's beautiful and the interesting people. You know, they're not dumb.
no, very different kind of smarts though.
Yeah. Yeah.
And
Yeah.
you said that your family was from Scotland and
My father
from
was Scottish, but my mother's American. Yeah. For many, many generations. Yeah. Yeah. But I was glad to come to America. You know, it was the promised land.
yeah.
Yeah. When I was a kid in Scotland, it was still bombed out after World War II, and you didn't get enough to eat, you know, and it was just amazing coming to America where you could have all you wanted to eat. You could have seconds if you wanted. It was just a different world. So
Yeah.
people, I'd been in America, as I mentioned, during World War II for a year or two because my mom was at the Oak Ridge plant. But that was because my mother and father met in India. They were both doctors in India. My mother was a medical missionary, and my father was an army doctor. And so in the British Army. So when World War II broke out, he was, of course, going to have to go to war. And he was worried that the Japanese would invade India while he was at war and was not able to protect his family. So he put us on a boat to come back to my mom's home in America. So we came back to America in 1941, I guess, just before the Japanese attack, and dodged German submarines the whole way because the Germans were sinking every ship they could catch. But we went around South Africa and up the coast of South America, and so we made it safely. And so anyway, my mom needed a job in America, so that's why we went to Oak Ridge, and that's how that probably influenced the rest of my life. And but as soon as the war was over, we went back to India, and so that's where I started school, and then I spent a year or two in Scotland after Indian independence. We went to Scotland, but you really couldn't make a living in Scotland at that time. It was as I say, all bombed out, and there were lots of returning colonials. There weren't enough jobs to go around, so we eventually came to America. Thank goodness. Yeah, we should all be grateful for our country, America, for all its faults. Is I can tell you, it's better than Scotland.
Yeah.
People are still lined up to get in every day.
Yeah,
Yeah, we
yeah.
lost your camera again.
Oh, okay. Yeah,
Yeah, I mean, I think about it. I think about it all the time. Like my dad in the Soviet Union, he knew that we had to get out, and a lot of his friends stayed, and they're still there, and they're still dealing with the fallout of Putin. And I look around, and there's definitely a lot that's you can point to and say, you know, it's corrupt and it's wrong and it's
yeah.
stupid and there's problems. But on the other hand, I don't think that there's any other place that compares. And I struggled a lot with it because I had to choose whether or not to become naturalized during
Mm,
the first Iraq war because
mm-hmm,
our green card had run out and
mm-hmm.
it was kind of, you know, time to act or to leave. My whole family was here, and I knew that it was something that was necessary to do in order to stay, but it was also a really difficult decision because I felt like it was tying me to something that I didn't admire. But as I've
Mm-hmm,
gotten older and as I've looked around more and I've gotten a better sense of global politics and I've gotten a better
mm-hmm.
sense of the unfortunate forces that drive the world, it's really become a place that I'm super, super grateful for.
Mhm. Mhm.
Because I feel like the same way that there's thermodynamics in physics where things have to happen a certain way, I think that
Mhm.
there's also a thermodynamics for politics, and there's a thermodynamics for people that we haven't really codified the rules for very well
Mhm.
yet.
Mhm.
And I think that if we could codify those rules a little bit better, we would be able to look upon history and the action of massive states through a lens that is not necessarily more compassionate, but at least less emotional.
Mhm. Well, look, you have to be optimistic.
Yeah, I do
So
appreciate that.
my advice to you is remain optimistic. And hope for good luck. Good luck counts for a lot in life, and we've all had good luck, and not everybody does. Yeah,
Absolutely.
yeah,
Hey, I have to ask before you go, do you ride your bike to work every day?
I do. Yeah,
That's wonderful.
yeah. Gives me a little fresh air. I enjoy it. The only time I don't like it when there's a lot of snow. I fall off. But
Wear a helmet.
I still ride it.
Yeah, be careful.
Yeah.
All
Okay,
right,
well, I
sir.
guess we should say goodbye then.
Yeah, thank you so much again. It's been wonderful to
Okay.
meet you.
Yeah, I hope we see you again.
Good luck to you.
To
Bye-bye.
you as well.
All right, bye, everybody.
Bye.